Okay, today is day 2 of linear programming, and the job for today is basically to help you see the whole problem from beginning to end, and I'm going to help you with a few of them, and that's going to teach you how to do them. So, Kesha, I know it's probably Keshia, I don't know, I'm going to go with Kesha, is a college student who is majoring in math education. She'd like to earn some money to help with expenses. Is that realistic? Yeah, you get a lot of college kids that need to, earn some money so they can pay for pizzas and maybe even part of their tuition and stuff. Pretty tough to actually earn enough to pay for your own college education nowadays, like the whole thing. But it is still done. You're not going to be going to like a place that's 50,000 a year and doing that. Like nobody can do that. But you can go to a place that's like one of your cheapest colleges out there. You can still do it to work and pay for your own college. She's got 2 part-time jobs. She earns $8 an hour tutoring at the Academic Support Center and $10 an hour working at a local restaurant. You might just say, in the real world, why doesn't she just work that $10 an hour job? And wouldn't you want to do the job that makes more money? What are some reasons why you might not just work the $10 an hour job? Maybe one's more flexible, okay. Maybe you like the job, even if it's $8 an hour, but you like it so much more. The other one's painful and it's $10 an hour. You're not going to probably want to do the $10 an hour job as much. Is it possible he might not be able to give you that much hours at each place? Maybe one pays really well, but you can only get like 3 hours a week. All right, so there's reasons why in the real world there are something called constraints. You are constrained by reality. Otherwise, if you can find a job that, like let's say your neighbor is super nice and pays you, $20 an hour to do some work in the backyard, does that mean you can just work forever for him at $20 an hour? No, that'd be a great job, but you can't just get that all the time. There are constraints. And so you write equations for those constraints. So here's some things that they want us to write equations for. The number of hours she wants to tutor. There's 2 constraints for that. Now that number of hours she tutors, does that include both X and Y? Are those both tutoring hours? No, one of them are restaurant hours. So by saying tutoring, they narrowed us down to what? Just X is the tutoring. Tutoring is academic support center. That makes sense? So these are X equal things. Do they have to be equals? No. Could be greater than, could be less than or equal to. So what do we know about the academic support center? Although she would like to work more hours at the tutoring center, she likes earning the higher pay at the local restaurant. She can tutor no less than, this is the tutoring part. She can tutor no less than 2 and no more than 8. That sounds like equations to me. Do you have them already? Okay. Who has got them already? Because you just saw it from when you saw it. Yes?
2 is less than or equal to x.
Give me them in 2 separate equations, though.
Oh, okay.
X is
greater than or equal to 2.
Greater than or equal to, stop for a second, let's make sure people understand that. That's the no less than 2. No less than 2. Why would a job require you to keep working? Well, because they don't want to have you on staff if you're never going to work. They want you to work 2 hours a week at least. Is that reasonable in the real world? Yeah, they do that. Okay, I mean, every now and then they might let her off for a week to go with her family or something, but no less than 2. No less sounds like greater. But you can't just change it to greater because it could be 2. When it says no less than 2 implies 2 is okay. So anyway, no less than means greater than or equal to 2. All right, now give me the other equation.
X is less than or equal to 8.
How'd you know it was or equal to? I mean, it's pretty obvious it's going to be an 8 because this is no more than 8. How did you know it was less than or equal to 8?
Just between 2 and 8.
Okay. All right, good. No more than, if you have to memorize it, no more than means less than or equal to. All right, so there's our 2 constraints. Could these be graphed? Yes, they haven't asked us to do that yet, so they don't have to worry about it for now. But okay, next thing. The restaurant. Well, obviously we're changing the letters to Y. And who can tell me these? They never said anything about the restaurant. So how am I supposed to write an equation about it? Common sense would tell you something about how many hours you can work at the restaurant. Less than 24. Now that's per day. This is this per day or per week or what is this? This is per week. So I would agree that there's a common sense about the total, like, but 24 may not be it. How many hours per week could you theoretically work? Well, in theory, you could work all the time, right? But 168, does it actually come out to that? That's how many hours are in a week. All right. Well, I'm going based on, if I go 7 days a week, and would you say, I don't think it's even legal unless they pay you overtime to work more than 8 hours in a day. I mean, in special circumstances maybe, but sometimes it'd be 56. So I'm going to go with 56 possible hours. But just so you know, I'm kind of overthinking the problem a little bit. The common sense one that they usually talk about is it has to be bigger than what? Think about it. Bigger than or equal to what? You're saying she has to work 7 hours at the restaurant? Is there something logically? That's what I want you to think it through. Like, it's talking about restaurant hours. What's logical? I know you're thinking, oh, she has to work one shift. Did it ever say that she had to work one shift? No. Could she work -6 hours? No. So 0. There you go. That is called the common sense number. Because you can't work negative hours. You can work 0 hours. Now, at this other place, you can't work 0 because it said you had to go at least 2 hours a week. But this restaurant, apparently the restaurant doesn't care. It'll let you not work that week if you want to. So whenever they say common sense constraints, look for the greater than zeros or greater than equal to zeros. Okay, total number of hours she can work during 1 week. You could say something separate about X and Y, but it'd be much smarter to say it together. X plus Y. And now what would you say about that? We never actually read it. What is Kesha's maximum earning potential if she works for a total of no more than 20 hours per week? That's the key right there. Less than or equal to 20. You got it. Do you get, we just wrote a whole bunch of equations from a situation. That is like an ACT skill. That is one of the things they expect you to be able to do. Here's a word problem. You write equations. Yes, that is definitely part of, like, they may not use the words common sense, but they would expect you to go, okay, in the context of this situation, I can't have negative y's, so therefore y must be greater than 0. I'm just saying the words common sense constraint are not like a math term you have to know. It's just about the real world. In the real world, using common sense, you know you can't work negative hours at a restaurant. All right, next, graph this system. Sketch your graph and label the vertices. So from this point, it's exactly like yesterday. Remember how yesterday you just graphed? Well, now you have to make the equations and then graph them. Okay. So if you're going to do this one, is the only hard one. You go solve it for y first. Once you get it graphed, the cool thing happens. The feasible region, the like thing you shade in with everything, that's all the possible work combinations she could do. She could work like 6 hours at the restaurant and 2 hours tutoring. Or she could work, and you find the goal when you're all done is to find the one that makes her the most money. Should that be your job in life? No. But if you're a company, it's actually part of the rules of a corporation as they're trying to make profit. So they have to act in the best interest of the shareholders of the company. Well, just a person. But in the real world, usually people are working because they want to make some money. And it does say she likes her $10 an hour job. That'd be different if she didn't. She just hated it. And then maybe you could make the argument she should just do the 8-hour an hour job. $8 an hour job. All right, so get these things graphed. And when you're done, I want you to circle the corners of the feasible region because those are the special spots. I'll pause for a second while you try that. Okay, I got my recording going again. So I've got this thing graphed. The only line I don't have is this one. So after I graph this one, which starts at 20, it's hard to tell exactly where 20 is because I don't have graph paper, but it goes down 1, rise 1, run 1, rise 1, run 1. So in this case, fall 1, run 1, fall 1, run 1. It's shade underneath it. Better extend this up a little bit further. And then the feasible region will be in here. All right, you said wait. You have a question?
Why isn't you just go down one?
When I was doing this one, here's the way you could like make this part simpler. This is -1 over 1 x, and that's rise over run. The rise is -1, which means fall 1, and this part means run 1. So fall 1, run 1. That's what I'm doing to get down, 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 down. Okay? Delete that last little part there. There we go. Now I said to circle the corners because that's where the magic happens. That spot, that spot, that spot, and that spot. I can tell right away which one makes her the least money. I'm going to call them A, B, C, and D. Which one makes her the least money? D, because she's only working like 2 hours at the one restaurant and none at the other. Okay? Which one makes her the most money? Which one would you rule out? It can't be A, or it can't be D, because that one's the least money, obviously. What other one would you rule out? And it can't be with C. It's hard to tell, though, between A and B, which one gets her the most money. Okay, because you don't know for sure until you check which one pays more, because see, there's different amounts for each. So you'd have to say this one's got more, let me think, that one's got more Y in it, and this one's got more, it goes over further like this. So B has got more X in it, more Y, and this one's got more X. The kids at home can't see that, I apologize. This one's more Y, this one's more X. Well, which pays better, X or Y? Y pays better. So the one that has more Y in it, which is this one, is probably going to be it. All right, there's an official name for that thing then. That is, you are what is called maximizing, and they sometimes call it the objective function, or sometimes they call it the profit function. When you are picking the one that makes you the most money, there's a function for that. Do you get for every X that you do, which is the tutoring hours, she's getting 8 for that, plus, tell me what the other part is. Come on, you can do this. If it's 8 for each X, then it's what for each what? 10 for each Y. See? That's a function. And sometimes they say it's profit, or sometimes they say it's cost, or sometimes in this case, could you say it's her profit? It's kind of profit. She might have some expenses, but I mean, she's a waitress. Maybe they make you buy your uniform. That's sometimes something a waitress would have to do. So if she makes $700 for the month, she might have had to pay $100 for a uniform, so now she only made 6. Yes, there's absolutely taxes involved. You're right. And yes, waiters can make good tips. There was rumors at one of the local restaurants, I won't name it just in case because it's on the video, but there were some people who were making $500 a night in tips at a local restaurant. Okay. So anywho, we've got these 4 spots. This is called the profit function, and you can stick this point right here, which I think is going to be the winner, and it's at 2, where does it intersect up there? I think it's 2,18. I know it is. So that's 2,18. If we had a better graph, it'd be easier to read that. Then X is 2, and Y is 18. Why is it really going to make us the most money? Because we got more of that $10 an hour job in there. We got 18 hours at $10 an hour, which is 180, plus this, which is 16, so that makes 196 total. This little spot right there makes her 196 bucks. So that's the most she can make under her constraints. Okay? Now the good part is she's not really not working that many hours. It's a total of 20 hours. And that is doable for a college student. So.
But I don't understand how the x equation that, because it's still, like, because the x is 2.
X is 2, so this spot right here is still 2 comma something. Do you get how this spot is 2 comma 18? That's a really important thing to get. That spot right there was over 2 and up 18 to get there.
Okay.
That's why it's 2 comma 18. That was 2 hours of tutoring and 18 hours in the restaurant. All right, these are complicated, I know, but you're only on day 2, and honestly, what I just talked through with you, that's it. That's everything you have to know. I'm just going ahead on this problem to show you the end. So that would be as complicated as they could get. Notice the keys. One is graphing, but you were all pretty good at that. The other is finding these 4 spots, figuring out exactly what they are, like what comma what are they, and writing this little equation for how much profit they make. Again, this was $8 for each hour of tutoring, and this was $10 an hour for each hour at the restaurant. All right, I know I got really messy, but I'm going to clear it all off. And now we can move on. Now, your homework for tonight is some of these same problems. I'm going to tell you which ones I want you to do. This optimization equation, that was that thing I just said a second ago where I said you could call it profit for her, even though there's not really a good name for this, so might as well call it profit. And that was how much for each x and how much for each y. What was that equation again? 8x plus 10y. That was her optimization equation. All right. And Kashia, is that what you're going with? Kashia's maximum weekly earnings. So that's where I figured out it was 196 for that one spot. And to do this right, you have to compare, in my world, you have to compare at least the top 2 numbers together. Okay? I don't need you to show me all the numbers because I think you can use logic. When you see a picture like this, can you tell right away? I can actually tell right away that one of these can't be it. It can't be the one that makes me the most money. Do you guys get that that one is low on both X and Y? That can't be the most money. Okay? Now, can you tell just by looking for sure whether it's A or B? No, you can't. Because you don't know how much money he makes on A or how much money he makes on B. Okay, so you have to compare at least 2 things. So on this problem that you need to finish as part of your homework, that's where you take some of those other points that were on the graph. Like one of them was, the other point that was in the running was like, what comma what? Can you see on your graph? 8 comma, I erased mine, so I can't see it anymore. But it was that point, it was kind of like this, and there was these 2 were the 2 that we knew were probably it. It's this other one, whatever that is. 8 comma something. You figure it out from looking at your graph. You got to compare it, because like the one makes 196 bucks. Make sure that the other one doesn't actually make more. You got to say, this one's 196, this one's, I don't know, 185, or whatever it comes out to. All right. So let's move on and see a different problem that you're going to do all by yourself as your homework. Eli's lunch cart, and there's Yakawa, and there's Jamal's investments. All right. I am going to have you skip the lunch cart. I don't like the lunch cart problem. It's kind of, yeah, I don't like that one as much. We're going to do the bikes and motorcycles. You can imagine a place that manufactures, like a factory, and they can either make all bikes or all motorcycles or some of each. If you could only make the thing that made you more profit, of course, that's kind of smart. But in the real world, do you think Apple is going to stop making their other things just because they make the most money on iPhones? No, in the real world, you want to have more products than just one thing. So like they have iPhones, plus they have Macs, plus they have Apple TVs, plus they have, they have other things. And they kind of like, they can sell things together kind of that way. So that's why you can't, in the real world, It's different than on a math problem. On a math problem, you just say, well, I want the most profits, so I'm just going to sell the thing that makes me the most money. But in the real world, sometimes you just have to sell a couple things to keep your customers happy. Okay, so I'd like you to do the Yakawa, and I'd like you to do Jamal's investments as your homework for tonight. Is it? Oh yeah, it's okay. Yawaka.
What do you do with your fingernails?
Pausing.